let me tell you about the properties. Oh, is this what yours looks like? 4-7. Shoot, this is weird. This is not what it's supposed to look like. That's not supposed to be a 3. This is greater than or equal to, and this is greater than or equal to. Is that what yours looks like? Yours looks like greater than or equal to? Or yours looks like this? This? Shoot. Sorry, guys. I don't know what happened. So change all those little 3's to greater than or equal to's. And I don't know why this turned into an X. It's just a dot. It's multiplication. But here's the idea. Okay, here's the properties that are going to help us simplify where simplifying is needed. If I take the square root of a times b, I can break that into the square root of a times the square root of b, and vice versa. Okay, if I have them separated, I can multiply them together and make it one radical. Okay, same goes for division. If I have the square root of a fraction, a over b, I can take the square root of the a and the square root of the b as separate things, or vice versa. I can take those separated ones and I can turn it into one fraction square rooted. Okay, so that's what we're going to be doing. But today is really just a day to make sure that we're comfortable with those ideas so that we can do what we need to do in the lessons to come. So this is not like the material we're trying to learn. This is the material we're trying to use to learn the things we're going to do next. So 3 things. We're putting all of these into what's called simplest radical form. And here's the 3 things. Your radicands, so your numbers that are under the radical, right? These are radicands, the A, the B, the A, the B, those are radicands. None of those can have perfect square factors. So none of those could have 4, 9, 16, 25, 36. They cannot be divisible by those numbers. Okay, and that's the first thing. The second thing is you cannot have a radicand that has a fraction. So we don't want this as a final answer. We don't want a fraction underneath a radical. So we're going to separate them and get rid of the radical in the denominator, because that's the third thing. You cannot have a radical in the denominator. Okay, so you cannot have the square root of something over the square root of something. Okay, that denominator has to be radical free. No radicals there. Okay. So let me just show you how we do this. There are 18 problems here. We're going to move fairly quickly. Tell me to slow down if I lose you, okay? But you've seen this before. You did this in Algebra 1, hopefully quite a bit. Okay, so you look at the square root of 50, and we said you cannot have any perfect square factors for the number that's under the radical. So, and guys, this list, you might just want to take a screenshot or take a copy and paste and put it at the top of your homework, just so you're seeing those numbers, because those are the numbers you're always going to try to divide by, okay? So you look at those numbers, and then you look at the number 50, and you say, is there a perfect square that 50 is divisible by? It is divisible by 5. Is that a perfect square? 25, right? So the perfect square, now here's how I always set this up. You don't have to do it this way, but this is how I'm going to do it every single time. So if you want to just get in the groove with how I do it, this is how I will do it. I'll take it, I always put the perfect square on the left and the one that's not a perfect square on the right, and you'll see why in just a minute. So the perfect square that 50 is divisible by is 25. Okay? 25 times what gets me 50? 2. So we're saying this is the same thing as this, right? We're breaking it down into an equal value, but writing it a different way. Okay, so now, once we're here, we have to simplify that further. What is the square root of 25? 5. The square root of 2, we cannot simplify. So this is the simplest radical form of the square root of 50. Okay, so 5 rad 2, 5 radical 2, that's how I'm going to say it, by the way, 5 rad 2. 5 root 2 would be the same thing, okay? 5 rad 2 is the same value as root 50, or the square root of 50. Questions on that? Okay, so moving on. Then you look at something like this. So the 5 is outside the radical. That's not the square root of 5, right? That's just the number 5. how could I break the square root of 12 into a perfect square and a non-perfect square? 4, right? 4 times 3. So 4 is a perfect square. Please don't forget about our friend out in front, the 5. I'm going to just write him there so we don't forget about him. So now you take the square root. What is the square root of 4? 2, right? What are we doing with the 5 and the 2? We're multiplying. When you put something right next to it like that, that implies multiplication. So it's 5 times 2. The square root of 3 we can't simplify. So that becomes what? 10 rad 3. Okay, so your answer is 10 rad 3. That make sense? Okay, now we're going to throw a variable in the mix. You're looking for a perfect square and not a perfect square. So let's just think numbers first of all. The number 700, what perfect square is 700 divisible by? What? 100 is the perfect square, right? So we put that on the left, 100. We put the 7 on the right. Now look at variables. Can you take the square root of x and simplify that? What if it was the square root of x squared? Could you take the square root of x squared? Yes. Okay, so because it's just the square root of x, we can't do anything with it. So we're going to put that on the non-perfect square side. Square root of 100, rather, is 10. The square root of 7x, we can't simplify, so we just leave it as the square root of 7x. Okay, so you're always looking for perfect squares. If you can take a perfect square, take the perfect square. If you can't, leave it as that 7x under the radical. Okay? Okay. Questions on those? Yeah, John.
What if there was one that they both perfect squared into?
Then you could have taken the perfect square from the original number. Are you looking at a certain number on here?
No, I was just thinking.
Like, let's say you had the square root like something like that, right? You would go, oh, well, I could take 25, what is that, and 9, right? But both of those are perfect squares. That means this is a perfect square.
Okay.
So if you can take the square root of it right off the bat, then do that, right? The square root of 225 is 15. So go there if you can, yes. Okay, this one looks a little different. We said we cannot have a fraction under our radical. So we're going to break this into the square root of 2 over the square root of 3. Does anyone remember how to rationalize this fraction? There's something you can multiply by to get that radical out of the denominator. Anyone remember it? What can you multiply something by that doesn't change the value of it? 7 times what would get you 7 back? 1. Okay? So we have to find a way to multiply by 1, but get the radical out of there. Anyone remember what you do? Not opposite reciprocal. You multiply by the radical over itself, right? So if I want to get rid of the square root of 3, I'm going to multiply by the square root of 3 over the square root of 3. So I'm multiplying by 1, right? But it's going to change that radical setup. Okay, so here's what you do. Multiply by the radical over itself. What do I get in the numerator right now? What is the square root of 2 times the square root of 3? It's the square root of 6, okay? That's not a perfect square. It does not have a perfect square factor. So you're just going to leave that as the square root of 6 right now. What's the square root of 3 times the square root of 3? It's the square root of 9, which is 3. So here's the shortcut, if you want a shortcut. A radical times itself is always the radicand. It's always the number under the radical, right? The square root of 3 times the square root of 3 is 3. The square root of 4 times the square root of 4 is 4. But if you take the long math version of it, the reason is the square root of 3 times the square root of 3 is the square root of 9. And when I square root that, it's 3, right? So I don't need to see this step from you, but if you need to do it to remember it, then go for it. I just need to see that you got to that point, okay? Now here's the thing. A radical divided by a whole number or an integer is not divisible. So don't call this the square root of 2, okay? This is not the square root of 2. This is the square root of 2, right? Sorry. Yes, square root of 6 divided by the square root of 3, it would be the square root of 2. But this is not the same as that. So please don't do this on this problem. If one's a radical and one is not, you cannot divide them, okay? Okay, so rad 6 over 3 would be your final answer there. Okay, now this one's a little bit trickier because you have options. Here's your options. The first thing we want to do here is call this the square root of 5 over the square root of 12. Does anyone know one of the options you could take right now? What could you do? How about multiply by the square root of 12 over the square root of 12? Could you do that? Anyone see a different way you could do it? You could break this down right now into a perfect square and non-perfect square, and then you would multiply by something smaller in the end, but you would have that, it would be a 2 in the denominator right now, right? You'd have the square root of 4 times the square root of 3 is 2 rad 3. So you can either think of it as this, or you can think of it as this, okay? If you set it up this way, then you would just multiply by rad 3 over rad 3. And that would get rid of your radical in the denominator. If you think of it this way, you're going to multiply by rad 12 over rad 12. Which do you prefer? Because I really don't care. Which one seems easier to you? Thoughts? The rad 12? Okay, let's try that first. Oops, there we go. Okay, so if I take this, let's forget about this for a second. If I take this and I multiply by rad 12 over rad 12. First of all, what's my denominator going to be? What's rad 12 times rad 12? Any radical times itself is the radicand, right? The number underneath. So you should get 12 here because that's the square root of 144, and the square root of 144 is 12, okay? On top, what do you get? What's 5 times 12? 60, okay? So you get the square root of 60 on top. That can be broken down. Anyone know the perfect square that goes into 60? 60 is divisible by which of those numbers? Calculators are super helpful in this section, by the way.
16.
Not 16. It is divisible by 30, but 30 and 2, neither one of them is a perfect square. We need a perfect square that 60 is divisible by.
4.
It's 4, okay? And you can just plug it into your calculator. 60 divided by 64 doesn't really make sense, but you can do it. 60 divided by, just work your way down. 36, 25, 60 divided by what? 60 divided by 4 is 15. So this becomes the square root of 4 times the square root of 15. Okay, what does that get us in the numerator? What does this become? So the square root of 4 is 2. The square root of 15, we can't simplify. There's no perfect square. And it's over 12. Final answer? What can you do with that? Right now we have this. 2 rad 15 over 12. Divide by 2, right? Everything's divisible by 2 here. 2 and 12 is going to become 1 and 6. So you get the square root of 15 over 6. Is it coming back at all? Oh, COVID. How I loathe thee. All right, number 6. You have the square root of 3/4. What should you do with that? Break it into what? Square root of 3 over square root of 4? Is that what you said?
Square root of 4 over square root of 4.
Do you need to do that? Think of it like this, the square root of 3 over the square root of 4. So you could, if you multiplied by the square root of 4 over the square root of 4, you would get there, but you're going to do way more work than you have to. Why? The square root of 4 is a perfect square, right? So you can just do the square root of 3 over 2. Can I divide that? Even if it was divisible? No, it's not divisible because one's a radical and one is not. So that's your answer. Okay, you try number 7. Number 7 is the square root of, 6 divided by the square root of 2. Give it a go. What are you going to do to work that one out? What'd you do? Can't divide by 2. One's a radical and one is not. How do you get a radical out of the denominator? Multiply by 1. But what is that 1 going to look like? Rad 2 over rad 2, right? We're multiplying by 1, but that's going to get our radical out of the denominator. So on top, you have 6 rad 2. What do you have on bottom? Rad 2 times rad 2 is the square root of 4, which is 2. Okay, what's your final answer? Not that. 3 rad 2. 6 over 2 is 3 times the square root of 2. Okay. Did you get that? Yeah, hopefully. Okay, now look at how similar these are. This was 6 divided by the square root of 2. This is the square root of 6 divided by the square root of 2. You do very different things. What can you do with this one? Divide, right? If they're both radicals and they're divisible, you can divide them. What's the square root of 6 divided by the square root of 2? The square root of 3. And you no longer have a radical, and there is no perfect square that 3 is divisible by, so you're done. That make sense? Okay. Number 9. What are we going to multiply by here? By what? Square root of 3 over the square root of 3. Where are you getting 21? You're multiplying them together. Yeah. You want to multiply by something over itself, right? We want to multiply by 1. So the square root of 3 over the square root of 3. What is your denominator? 3, right? A radical times itself is always the radicand, the number under your radical. So this, when you multiply, becomes what? 3, and then the square root of 21. So what's your answer? Just rad 21, right? 3 over 3 is 1. So you get the square root of 21. Can you break that into a perfect square and a non-perfect square? No, its factors are 3 and 7 or 1 and 21, right? Neither of those are perfect squares, so you just leave it like that. Ready to get a little fancier again? Now we're going to throw some operations in for you. Okay, so take a look at this. Notice the ones we've done so far, there's no plus, there's no minus, there's none of that. When we throw the operation in, things change a little bit because now every part of our setup has to be divisible by whatever we're going to divide by. Okay, it's not just the numerator and denominator are both divisible by something. So the first thing you want to do here is you want to simplify your radical. Can you break the square root of 20 down? 5 and what? The perfect square and the non-perfect square, right? So I would go the square root of 4 times the square root of 5 is 2 rad 5. Okay, so let's take a look at this. This is 2 rad 5. So we have 4 plus 2 rad 5 divided by 2. Okay, now the error that gets made the most on this type of problem is people see this and they divide it, but then they forget that they also have to be able to divide that. So when there's an operation, when there's a plus or minus in between, you have to be able to divide by this number on both sides of that operation. Both sides of your plus sign, you have to be able to divide by, okay? What do we get here? 4 divided by 2 is just 2, right? We're going to divide that. So that's 2. What do we get here? 2 divided by 2 is 1, but we still have the rad 5. So it's just 2 plus rad 5. You can write 1 rad 5 if you like that, but you don't need to. Okay? Questions on that? Okay, I want you to try number 11 then. Same idea, it's just subtraction instead, but see if you can break that into the perfect square and the non-perfect square and simplify. Don't forget, list of the perfect squares is always helpful if you're struggling with what perfect square is there. A little bit trickier depending on how you want to set up your final answer. Got some options. Anyone have an answer for me? What'd you get, John?
I got 1 minus 5 rad 2.
Okay. We don't want decimals in our answers, so you'll leave it as fractions. So what would that be instead? Do you know?
1 minus 1 half.
Right. Yeah, so really rad 2 over 2, or you could say 1/2 rad 2. Did anyone get that? Or something close to that? Yeah? Here's what I would do, okay? I'm going to ditch this for now. Break this into what perfect square and what non-perfect square? 9 and 2. Okay. So this is 6 minus 3 rad 2 over 6. Now, you cannot divide everything by 6, right? This is divisible by 6, but this is not divisible by 6, but it is reducible. You can divide both by 3. So what we would do here is I would separate it. I would call this 6 over 6 minus 3 rad 2 over 6, right? That's perfect. You're able to do that. We're just turning it into 2 separate fractions that we're working with. So 6 over 6 is 1 minus 3 over 6 would be 1 over 2. So rad 2 over 2, and that would be your answer. Now, if you didn't do it that way, well, I would do it that way. Just do it that way. It's better. Questions on that setup? Okay. Look at number 12. Very similar. I'm going to do this one fairly quickly since we've done it twice already. This would be the square root of 4 times the square root of 3. Okay. So that's 2 rad 3. So we're going to say negative 6 plus 2 rad 3 over 4. What are all 3 of those pieces divisible by? 2. Okay. So if I reduce everything by 2, if I divide everything by 2, I would get negative 3 plus rad 3, right? I'm dividing this by 2, I'm dividing this by 2, I'm dividing that by 2 over 2. And now nothing else is simplifiable. So that would be your answer. Okay. If you told me negative 3 halves plus rad 3 over 2, that's really the same thing. I think this one's simpler, but I wouldn't mark you wrong if you turned it into that. That's fine too. Okay. Okay. Home stretch. I feel like these ones get a little bit simpler again. The square root of 2 times the square root of 14. What do you think you do with that? We can't break down the 2. because there's no perfect square that 2 is divisible by. And if we break down the 14, I mean, you could, and in the end, you're still going to get there. I don't think it's the best method. Anyone see a different way to get there? What would you do? What's the square root of 2 times the square root of 14? The square root of 28. Okay, so if I multiply those, I get the square root of 28. Is there a perfect square that 28 is divisible by? 4, right? 4, 9, 16. You just go through the list. Can I divide 28 by any of those? I can divide by 4. 4 times 7 gets me 28. So what's your answer? 2 times the square root of 7. All right, I want you to try 14. Think about what this means. So 3 rad 5 squared. So we're squaring that whole thing, right? These parentheses, it doesn't really look like it, but the parentheses are around this whole thing. What do you get when you square 3 rad 5? See if you can figure that one out. What'd you get? 45. Did a lot of you get 45? Good. So if we're going to square it, square both parts, okay? That's 3 squared and the square root of 5 squared. 3 squared is 9. The square root of 5 squared. So if you square something and square root something, those undo each other, right? They essentially cancel each other out. It's like saying this. The square root of 5 times the square root of 5 is the square root of 25, which is 5, right? When you multiply a radical times itself, you get the number underneath the radical. So this is 9 times 5, or 45. Okay. Almost there. So what do you do with this? What can be multiplied here? Not the 2 and 7. No. Which ones are radicals? The 2 and 8, right? So you are allowed to multiply when they're both radicals or when they're both not radicals. These are both radicals. So this would be 7 times the square root of 16. What do you do with that? It's 4, right? That's a perfect square. Don't forget to look for perfect squares in your numbers. The square root of 16 is just 4. So this is really just 7 times 4. So 28. Those are the lovely ones. All right, what do you get for 16? Yeah.
So for the last one we just did, why was it square root of 16?
Because 2 times 8 is 16, and those are both radicals.
So you can,
Right? We said if you have the square root of a times the square root of b, you can call it the square root of a times b. Right? So the square root of 2 times the square root of 8 is really just the square root of 16. You're multiplying those together. What do you get here? The square root of 100 is 10. What's the square root of a squared? A, right? The square root of a squared is just a, so you get 10a. Do you know how square rooting with exponents goes? What's the square root of a to the 4th power? A squared. You divide it by 2, okay? So the square root of a to the 10th is a to the 5th. The square root of a to the 4th is a squared. You're just dividing the radical by 2, okay? You can only do it with evens. We'll get into that eventually, but not right now. Okay, this one. Now, this one can get real ugly if you don't do the right step first. Does anyone see something that we can do to simplify this before we start multiplying by things? Take out an x. X to the 3rd over x is really x squared in the numerator, right? And that's much lovelier. So we're going to call this the square root of 2x squared over the square root of 3, because we're going to reduce that x, call this x squared, and get rid of that x in the denominator. Okay, now from here, we can take the square root of x squared. What is that? It's just x. Okay, so the square root of x squared is going to be x. The square root of 2 we can't simplify, and it's over the square root of 3. How do I get the radical out of my denominator? You need to multiply by rad 3 over rad 3. Okay, so now multiply this. What does this become? X rad 6 is your numerator, right? Just multiply across. Rad 3 times rad 3 is 3, right? The square root of 9 is 3, and that is your answer. Okay. This is another one of those where there's one way that is a little more work, and there's one way that is a little less work. If it were me, I would take that 2 to the 4th. Anyone know what 2 to the 4th power is? 16. Okay, so this right now is the square root of 16 over 50. Now, people see that and they go, oh, the square root of 16 is 4. I'm going to do that. I wouldn't do that. Do you know what I would do next? What do you think? Instead of taking the square root of 16 and the square root of 50, is there something else? Divide by what? 2, right? That's reducible. And the reason I would do that is because if I divide everything by 2, I get the square root of 8 over the square root of 25. Why did that help us? It gets that radical out of our denominator immediately, right? Because that's a perfect square. Otherwise, you're messing with something that's not a perfect square, and then you got to multiply to get the radical out. So just look for options. If you can reduce first and get a perfect square, do it, okay? So this becomes the square root of 8. What can you break that down into? 4 and 2. Okay, so this is 2 rad 2 for your numerator, 2 rad 2. The square root of 25 is 5. And look how simple that is if you do it that way. If you do it the other way, it will work. Do you want to see it the other way? Or are you good? I'm just going to show you. If I took the square root of 16 over the square root of 50, okay? This is 4. This is the square root of, hold on, square root of 25 and square root of 2. So this is 4 over 5 rad 2. And now you have work to do still, right? You'd have to multiply by rad 2 over rad 2. So you get 4 rad 2 over, what did I just say? 5 times 2 over 10. And then that has to reduce to 2 rad 2 over 5. So they both get you there. This one's way more work. So take the one that's less work, or try to anyway.